You all have heard of dating in social circles when boy dates a girls or vice versa. So we geologists date rocks. So what it means is we try to find out the age of the rocks when it formed. And as we know, the Earth is 4,500 million years old. It has grown over time. So we geologists try to identify different parts of that time period after dating of rocks or finding out the age of rocks. And Prabhakar is a, what we call them, geochronologists who date rocks. So he is a PhD from IIT Kharagpur, and he has been with us for last 11 years or so. And we have a national facility called Electron Probe Microanalyzer, which is a which does this work, and he runs it very successfully. Not only carries out research, but also provides data to different universities of India. More than 25 universities, students, PhD researcher, professors from more than 25 universities of India come and use our machine, and we give them data. So with this brief introduction, I request him to present his work.
For the introduction, and I also thank IRCC for recognizing our work for this research publication award. Our lab at Crustal Metamorphism at IIT Bombay, so basically focuses on metamorphic rocks and deformed rocks. So basically what we do with this, studying these metamorphosed rocks and deformed rocks, so we apply and try to understand the fold belts of India. So the title of my talk is Technothermal Evolution of the Great Indian Proterozoic Fold Belts. So here I use the term technothermal, means it's a structural evolution as well as the metamorphic evolution of the rocks. Proterozoic is referring to the time period of the Earth's evolution, which is between 2,500 million years to 540 million years. Now, I also use the term GIP-FOB in short form, and it is also known as Great Indian Proterozoic Fold Belt, which is a large-scale fold belt covering different parts of the India. So I show that here you have a Aravalli-Delhi fold belt, Central Indian Tectonic Zone, which is also known as Satpura Mobile Belt. In North India, there is a Shillong Meghalaya Complex, Eastern Ghats Mobile Belt, and Southern Granulate Terrain. So all this becomes the part of GIP-FOB. However, I am focusing on Aravalli-Delhi fold belt as well as the Satpura Mobile Belt in the Central India. Now, in my subsequent slides, I will tell you how I connect the micro scale features to the macro scale, which is in the hundreds of kilometers long. So for that, I start with the theory of plate tectonics. So we know that the Earth has different layers, and the top part is known as lithosphere. It has a crust as well as the upper part of the mantle. So that rigid part is divided into different continental blocks. So the interaction between these different continental blocks gives the different aspects or different geological features on the Earth. So basically, we have a transform faults, divergent plate boundaries, and most importantly, there is also a convergent plate boundary. That means here these red lines indicates the divergent plate boundary, whereas the black lines indicate the convergent plate boundary, where the different plates are collided to form the mountain belts. So if you see that continental collision, the collision of these continents creates a long linear mountain belts. Now you can imagine this with the collision between these two cars. You can see that the collision zone has the folded. So same thing happens to the continents also. But the problem, the most interesting thing is that there is a repeated amalgamation between the different continents. So that creates the polydeform terrains and polymetamorphosed terrains on the crust. So what happened when there a collision happens between the different continents or different crustal blocks? So you can imagine that from this clip that there are two different continents, and wherein there is a block migrated and collided with block A, and it generates the features of structures. It also generates the minerals. Now this again collides with B and forms another set of structure, another set of minerals. So this happens in the entire Earth's history repeatedly with the different crustal blocks. Therefore, ultimately what we have is the disintegrated domains or disintegrated crustal blocks like we have continents today. So these continents, I focus on the composite domain where it has a different blocks and try to unravel the information in the Earth's history. So if I link that in India, so this is my focus area, that is the Aravalli Delhi Fold Belt, and in central India we have a Satpura Mobile Belt. So this zone of amalgamation is basically formed due to the collision between North Indian Craton and the South Indian Craton. So basically they were not together at some point of time in the Earth's history. So I am talking about the time of the Proterozoic, and the Proterozoic, you can see it's in the millions of years, and especially this collision occurred around 1,000 million years ago. So now how do I understand, how do I unravel this information? So we basically study the structures. So the structures in the sense, the rocks behaves like a structure. The lithosphere, when there is a collision, it behaves like a paper. If I take a thin sheet of paper, if I apply stress, it gets folded. The same thing happens to the lithosphere, and it is recorded in the rocks in terms of multiple folds. So what we do in the field work is we document these different deformation events, different episodes of deformation, and we try to synthesize this structural information. In addition to that, when there is a collision, the rocks also bury it. So there is an increase in the temperature and pressure. So what happens to the rocks when there is increase of temperature and pressure? They form new minerals. So that is what it's shown here, that fine grained rock, there is an increase in the grain size, and also they form new minerals at the expense of the pre-existing minerals. But I also mentioned that there is a repeated amalgamation of the blocks. But what happens when there is a repeated amalgamation to the minerals? They develop zoning. So that's what we do using the electron microprobe. We try to understand these minerals, which I showed here. The garnet is one of the mineral, staurolite is another mineral. But I show the map of X-ray element map of the garnet, where you can see it has a beautiful zoning, and this zoning records the different episodes of amalgamation in the terms of chemical variation. So this is one of the aspects. Now, how do I apply this chemical variation? So we used to understand that for the pressure and temperature calculation. So we don't use thermometer or barometer to calculate the pressure and temperature, but what we use is the mineral thermometers and mineral barometers, which we call them as geothermobarometers. That is basically done based on the mineral reactions at the equilibrium conditions, and that applies the Gibbs phase rule, the Gibbs rule, which has basically applies the activities of the different compositions. Now, this is how we get the pressure and temperature values. Now I need to know when this deformation occurred or when this collision occurred. For that, we have to understand the chronometer, that is the timing. The timing is recorded again in minerals, the tiny minerals. So you can see, I show you the schematic diagram here. The red one is basically one of the mineral like monazite and zircon. So you can see the size of this mineral, which is about 100 microns. So if I magnify this image, you can see that it has a different zones, and all these zones were formed at different times. So the dating of these minerals, the tiny minerals, will give the timing of these events, the metamorphic and deformation events. So finally, we synthesize the work from the structures as well as the PT estimation and the timing, and try to say what happens to the collision zone between the cratons of India. So this shows that there are different possibilities. Now, one of the possibility that we encountered based on our work and the literature work, it says that the Aravalli Delhi Fold Belt and the Satpura Belt has a mosaic of blocks. They were not formed together at the same time, but they were amalgamated at 1,000 million years ago. But before that, they had an independent and different history. Now, most importantly, this has a bearing on its correlation with the supercontinents. The supercontinent is a time when large amount of or most of the continents were together in the Earth's history. So that happens in several times in Earth's history, but this was the time I'm talking about 1,000 million years ago, where India was sharing contact with Antarctica and Western Australia. So you can imagine that India was not at current position, it was with Antarctica and Western Australia 1,000 million years ago. And same thing was the case with North India and South India, and they were not together at some point of time. They came together at 1,000 million years ago. So this is what our study says at IIT Bombay from last 10 years which I spent here. So I acknowledge all my students, especially Joseph D'Souza and Tenzil Deshmukh and Hrishikesh, Suranjan Ghosh. So all these 4 students did PhD with me, so they contributed immensely for this work. And I also acknowledge all my faculty members, IITB, IRCC, and SERB for the funding. Thank you.